Now, there's a last step in the assignment. Which is this thing called an adjacency matrix. This is actually going to be useful in our calculations later, so I'm going to make you do it now. An adjacency matrix is basically a table of values where the rows and columns are the nodes. So in my little graph creator, if I run this, say A, B, C, let's use numbers for edges. So right now I have a graph that looks like this. There's A, B, and C. There's an edge between A and C, an edge between A and B. So the way this would look in a table is matrix. You would have A, B, and C along the rows, A, B, and C along the columns. All the diagonals are irrelevant. Is there a connection between A and B? There is, and that's in the adjacency matrix. You just put a 1. So this could be 1 if you want it to. It's irrelevant. That means that there's also a connection between B and A. Is there a connection between A and C? A and C, yes there is. So this will have a 1, and this will have a 1. Is there a connection between B and C? No, there's not. So this will have a 0, and this will have a 0. So this is what a completed adjacency matrix will look like. And the way this works is that basically if you look up a particular node in the column and then check another node in the row, you'll be able to tell if there's an edge between them. The idea with this is that we'd like to be able to quickly go through the graph wherever we are and check to see what things it's connected to. And all we have to do is just walk down the column and look for 1s, and that's what it's connected to. So how do we update this? This is going to be a 2-dimensional array. I'm going to use an array list. So an array list of array lists as the size is going to change. And I think that I'm going to use a series of Booleans for this. Wherever the node is in the array of node list, so in graph panel over here, he's going to be the one holding this. So the node list is whatever order it is, 0, 1, 2. That's going to be the nodes in order. So in our case, when I created A, B, and C, this is index 0 in node list, index 1 in node list, index 2 in node list. I'm going to use that in my array list as well to define it. So to begin with, there's going to be an array list of array lists. Do I need to do it again? Let's do that. Boy, isn't that weird. So they want me to do this as well. All right, so those are the things we need at first. When I add in a node, what I'm going to have to do is update the rows and columns. So adjacency is going to add a new array list of Boolean values. So create a new list of array lists of Boolean values. And then for each thing in adjacency.size, Let's do A. I should spell that right. I'm going to want to add one thing into this array list, a false value, basically. So this will be adjacency.get adjacency.size -1 .add false. So each time I add a new node, I'm going to add a new column, and then I'm going to fill it with the number of things, the number of rows there are. So this should be the squared value of it. I'm going to need to be able to print this out. So let's go ahead and, let's see, I should probably create a print method, which I think I will just make outside of all of this. Maybe up here. Print adjacency. So this is going to be, I'm going to want to go across first. ArrayList.size. How about adjacency.size? And then do that again for the 0 slot. Well, it might be empty. We'll just use adjacency size for both. So my plan is that I'm just going to do an empty print line here to put a return in, and I'm just going to do system.out.print here. And all I'm going to do is I'm going to print adjacency get a, which will give me an array dot get e dot, well, that will be a Boolean actually. So that's all I need, plus a tab, which is a \t. So let's see if I'm anywhere close on this. So every time I add a node, let's do a print adjacency. False. That's good. Hooray, something happened. What happened? So when I tried to do this, it was like, I don't know what you're talking about. Oh. So I need to get our current thing, which is 1 less than the size of adjacency, which should be an array list, and add a false value, and then print it out. All right, so something I just realized I did is I need to add this many spots to this adjacency matrix. I also need to add an extra slot to each other one before this point. So all my other arrays that I had before, I need to add an extra slot to each of them as well. Yikes. That's kind of a triangle thing. That's kind of scary. So for each thing in adjacency, I need to add a false value to that. A. And that should be a semicolon. That's better. All right, so now we're getting the adjacency matrix. Now that we have that, what I need to do is I actually need to go through, and when I add an edge in, which happens down here in the add edge, I also need to print the adjacency matrix. But in particular, what I need to do is check to see what the first node is, and then what the second node is. and actually get those indices. So let me do an int for f index. Let's be explicit. First index, second index. Let's walk through the array of nodes. So if first equals node list dot get a, then first index equals a. So we're going to basically try and find the indices of the first and second ones out of node list. And the same idea here with second. Then I'm actually going to set the two values that go along with that. So I need to do adjacency dot get first index, which will give me the first array list, get second index dot, and how do I replace? So right now that's a Boolean. Can I just say set on the second one? Set. What a good idea. Sublist set. Give me set. There we go. And so I'm going to set at second index true. It's paranoid because these might not be zeros. We'll explicitly say that. So that's one side of it. And then second index and first is another thing I need to watch out for. So now true is on the two diagonals. And now if I add in another node, notice the true is on the two spots there. Let's see if I connect A and C, well, this A and this C. There we go. True to there, true there. Just because I'm like that, I'm also going to put an extra system print line here to make sure I separate these. All right, so that's the basic idea of this particular project. Creating nodes, creating edges, and creating an adjacency matrix that actually has those every time a new node or edge is created.